Hello, I am Thor. I am a rocketeer and a student of a school previously founded at the campus of SpaceX. And today I interview the CranSEDS Rocketry team at the Cranfield University. Could you please introduce yourself with your name and what you do in your team?
Hello, everybody. I am Rasika. I am currently project managing the CranSEDS team for European Rocketry Challenge. We are building our rocket Phoenix. The mission is quite interesting. You'll get to know our team is kind of very special, to be honest, because we have a lot of diversity. We have people from different places all over the world, people from India, people from France, Spain, British people, everyone. So we have a lot of diversity, and also the diversity included here is related to course as well. So we have diversity from chemical engineering, people from mechanical engineering, the specialized people, whoever are interested in building rockets. Also the age groups. So we do have people who are joining from various age groups, starting from, I guess I got a request from an 18-year-old person to join the group, which was very nice. And yeah, it's just superb to work in a team.
Hi, I'm Zoe. In this team, I'm the Electronics and Avionics Work Package co-leader, but I'm also the president of the Cranfield University Space Society. And kind of our mission is to more generally just engage and educate people about the space industry. And why rockets are an important part of that is that they give people the kind of hands-on experience that will hopefully be useful to them in a future career.
So I'm Paul. I was the project manager last year for the European Rocketry Challenge for CranSEDS team. So the rocket, if found, please return to us. And so this year I'm not anymore in the university, but I'm here online and to help the team and make sure they avoid the mistake we've made. And yeah, so I'm helping out with some other member from last year.
How did you start your rocketry club?
The society's been around for a long time. We know it's been around for at least since 2015, but it must be older than that. But our problem is that we're a postgraduate only university. So it's all people on 1-year masters or on PhDs, which means that we have almost a completely new group of people every single year. So every year we kind of have to start from scratch, which is quite difficult. Without an aerospace faculty, it would be quite difficult, but we definitely rely a lot on the university. We have lab space that they give us and some general support as well.
I have observed last year we went to EuRoC and we had kind of experiences with other teams which work on the rocket for 4 years, 5 years. They take a drop year and work on the rocket. So that kind of exposure, I guess we are missing here since we have just 1 year course. And our course is super intensive itself, plus managing the entire this big project such as EuRoC, or else working on this project as EuRoC is quite a challenge for us, because everything is quite new. Everything is technically new for us. So yeah, it's a bit of a challenge. But yeah, we are loving it. We are loving the process. And it's amazing to be in EuRoC. Last year was really amazing. So
how's your university?
Cranfield University used to be the Royal College of Aeronautics. So it's a university with a really strong aerospace background. And it actually has its own airport, which is awesome. So some of us actually get to go on flights. So we've experienced up to 6G and microgravity, which is awesome. Your arms kind of float like this. So that's really awesome. And it's in the middle of the English countryside. So it's quite remote, but it is very beautiful. It's very quiet. You do have to travel a bit to get to any cities, to go to the pub, to go to films. But yeah, that's the university. Oh, and it's postgraduate only. So everyone there has already completed their undergraduate, and they're kind of quite specialized.
The thing is, as it's postgraduate and a 1-year program, mainly, there are lots of people from pretty much everywhere around the world coming, mainly Europe, but also other countries such as China, India, Indonesia. It's really a mix of cultures. Last year, on 27 people in the team, we had 13 different nationalities. So yeah, it's very diverse and everything is in English because yeah, we're in the UK and and everyone comes from with a different background. Yeah.
Basically, the university offers various courses, starting from aerospace to water technology, chemical engineering, then manufacturing. Most of the courses that you might find on the website is related to aerospace. So we have astronautics and space engineering, aerospace vehicle dynamics, aerospace vehicle design, and manufacturing. Then I think there are some specialized courses for structures as well. So everything related to aerospace. So basically, this you could call it an aerospace university, not to like offend any other water technology students. Uh, then scholarship opportunities. We do have a lot of scholarship opportunities, such as we can apply for bursary or other Cranfield University grants. Following with there is a Cranfield University scholarship offered to students who have like some good projects in their background. So they do look for extracurricular activities in here. And we do have a lot of lab facilities. Unfortunately, we don't have manufacturing facilities over here. So most of the work needs to be outsourced. Yeah, we do have a research center, aerospace integration research center building, where we have the collaborations with a lot of outside companies like Airbus and Rolls-Royce, where students do projects like PhD projects or other research projects to tie up with the industry. And yeah, as Zoe mentioned, the flying experience is really good. So every student gets to fly in the National Flying Laboratory, which is a flying classroom, and also the Slingsby. So Slingsby is kind of fun. You do maneuvers such as barrel rolls, and then after a lot of barrel rolls, you get to puke.
That's probably the experience.
Yeah, so Paul had this experience, and when I went to that barrel roll, so I did, I guess, 4 barrel rolls with the pilot, and suddenly it was like a weird weird feeling going on that I'm getting sick in the flight. So it's kind of fun, and yeah, it's a great experience to be in this university overall. Yeah.
It is really intense because as most people are only there for 1 year, and it's not like an undergraduate where you have a summer holiday. You are working for 12 months of the year on your lectures and your exams and your coursework and your group design projects and your individual projects. So it's great, but it's really intense.
Oh yeah, the last point, like relative to the university, like as we have like a master's in space engineering, there are lots of other opportunities to work on projects such as CubeSats. Last year there was a CubeSat that was sent on a balloon with the Bexus, so with ESA. There are a lot of research projects working with ESA, and that's something that is really awesome.
Yeah, we did have the Solarsail project. So I guess the PhD students were developing the solar sails to be launched into orbit. It was like a drag sail or something, I guess.
Yeah, it was an aerodynamic drag sail, not solar sail, I think, for deorbiting satellites.
Yeah, and this year as well, we are working on like CranSEDS especially is working on a lot of projects. Like if you get a look into it, you would find like rovers, then satellites, and also like on-orbit service missions. And as well as we do have UK Rocketry team who is launching a rocket in UK itself for the competition. So it's quite fun to do all these extracurricular activities with the course. To be honest, it's amazing.
It's amazing, and just make the nights shorter.
Yeah, that's true.
Let's be honest.
That's true.
Yeah.
What are your job opportunities after your university?
The university has a really good career service. They are really lovely. They're really engaged, and they make you do a lot of stuff on LinkedIn. And obviously, because the space industry at the moment is quite startup focused, especially in the UK. So a lot of it happens on LinkedIn. A lot of jobs get advertised. A lot of the discussions happen there. So a lot of us are quite active on LinkedIn. But as I think both Paul and Rasika mentioned, our group design projects and individual projects are often supported by or sponsored by industry. So that really helps people to get jobs if they kind of work with the company and then go and work for the company after their degree.
We do have like good ties with the companies such as Satellite Catapult, then Rolls-Royce, and Surrey Satellite Technology, as well as Airbus. So there are good ties with these companies, and I guess after graduation, it's really easy to find jobs. It takes time. I guess it takes like 1 or 2 months, but almost like most of the people that are from my batch or that are from CranSEDS itself are placed at some good company. Even Paul has a great placement, and
Even Paul.
even Paul has a great placement. And the thing is that when we are talking in the interviews about these projects, such as that we do in CranSEDS especially, so it's a different experience where you yourself are engaged in a lot of activities and get to do extra projects. And this is like you have to manage the budget, you have to manage uh, on your own. You don't have faculties who will be looking into the project. So I think extracurricular activities give you an additional support in building up your career and giving you a path to have a secure job.
Yeah, definitely. Like there is a very large network, a lot of alumni, because currently there are about 80 students in astronautics and space engineering master each year. So that graduates. So each year it's like a batch of new people in the space industry. And as it has been, the master exists since, I think, 40 years. Like it's kind of old. And so I'm working now in a space company called Solarsail. And so in the company, like there are people from Cranfield, which are like from several years ago, like from like, so yeah, there are like a lot of people coming from this master. And I really think that's working on the side projects like EuRoC and also any kind of projects makes it easier to find a job, and yeah, and be good at it. it's important. Yeah.
Also, like in terms of networking, in UK we have the UKSEDS event, which is quite a big event, and we get to meet a lot of companies there. You find a lot of alumni, as Paul mentioned. So I guess I met like all the company ports, starting from reaction engines, then CGI, I guess DMV. There were like several lot of companies over there, and everybody had a Cranfield alumni present on their panel itself. So it was kind of interesting to network with them, and these alumni help us, support us also in such projects as well. So, and yeah, I guess Zoe would like to tell you that we did a great job last year and have an award.
Oh yeah, I forgot about that. Yeah, CranSEDS won the Branch of the Year award, which was kind of a lot to do with how we've managed to engage a lot of people from the university. Because as people have mentioned, we take people from every course. So Cranfield does have a specialist space course, but actually a lot of our members are from Rasika's course, aerospace vehicle design, or robotics, or any of the other many courses at Cranfield. So we really do try and make the space industry accessible to people from all backgrounds.
What high school did you attend?
Like like in Cranfield, it really depends on the people. Like everyone has like a different background. Most of the teams do not have any experience with rocketry when coming in CranSEDS. I think last year we were 2 or 3 people who has experience, but no one of the team launched a rocket before. Water rocket doesn't count, even if it's fun. It's still you learn stuff. But yeah, like before university, I think some people had like background in aerospace engineering, materials, some projects like hand-on projects, but not rocketry itself. That's something not a lot of people have. And I think it's something you can learn by yourself when you work in a team. And learning a team is even better because when you in a team, like there are more ideas that comes up. I personally had some experience, but I hadn't launched before.
I did bachelor's in chemical engineering, and I shifted to master's in aerospace because I did not like chemical engineering that much. To be honest, I liked making aerospace vehicles. So I joined a startup back in India. So I'm from India, and I joined a startup there. And there they trained us like the basics of rocketry. Like it started with quite a lot of basics. The startup is called as STAR, Space Technology Aeronautical Rocketry. So they are quite engaged in doing like outreach activities with students who don't have exposure much to rocketry. In India, we don't have actually specialized things such as rockets. It's mostly like mostly the aerospace engineering sector is based on aircraft design and stuff like that. So there is like a very less exposure to such kind of courses, and they were offering like great help in these internship programs. So I did like an internship over there, and then I joined them for like 1 year. We launched a number of rockets. So, but they were not that big that we manufactured in EuRoC itself. So EuRoC was the biggest rocket that I have been ever part of. So that's a really big project. But we did like a small rocket and then sugar candy propellants as well. So kind of little exposure to rocketry, but not too complex and not too complex as what we are doing now. So I guess it was of some help. I guess, and most of the team members that I've seen, some of the team members that we currently have do have experience in such competitions like Spaceport America. I guess we are having their experiences, our experiences, and we are combining each and every idea this year to finally build a great rocket and like correcting our mistakes from last year, basically.
As kind of Paul said, high school was basically over 10 years ago for me, which is scary. But my undergraduate degree was in chemistry, which is a bit different. And then I went to work in the submarines industry as an engineer for 3 years. And then after that came here. So you can definitely learn about space quite easily if you're just, as you know, because you're passionate about it. And when you look at who does amateur rocketry outside universities, outside companies, it's people from all backgrounds. So I'm part of a local society, as I mentioned. I think I've had about 8 or 9, I can't actually remember how many motors I've used, launchers with my rocket. And that has been quite good preparation. But actually, the complexity of the rockets that we do for EuRoC is on a completely different scale to what you tend to do in amateur rocketry. Especially with the 2-stage that we're doing.
What are your goals and your roadmap towards space as a team?
Short term, launch at EuRoC. Long term, I don't think we've mentioned it yet, but one of the many different project teams we have at CranSEDS is a research project to develop a hybrid rocket motor. It's a hybrid rocket motor and a test stand. And there's a hope that in the future that will be launched on one of our rockets at a future EuRoC competition, which is really exciting. It won't be this year, it might be next year. That's kind of, I think, what we're aiming towards as a society.
There are some team members who are quite interested in starting their own startups, building rockets, like building engines especially. So I guess I heard this from some of my team members that they want to use this knowledge to start building on a startup idea. And also mostly I myself am looking forward to it. If I get an opportunity to work in the rocket industry, it would be a really great pleasure. And I myself developing a big launch vehicle would be I don't know, like a dream come true, to be honest. I guess these things help a lot. And because of such projects, we do get insights into what career we want to look into.
Or again, Cranfield University 1-year program. So each year it's a new team. Again, we are repeating it, but that's true. Like each year, like it's a new society. So like when we came last year, when we were here, like it was after like COVID, like in between, like it was COVID. So we came and there was like nothing from the last years. Like we really came from scratch. So yeah, like I really enjoy working on rocket stuff, and now I'm doing myself and with also local societies, rocket society. And I think what's difficult to understand is like it's difficult to have like long-term project with changing teams. So personally, I'm like trying to help to keep maintaining something. And we had changed this year because Rasika is like from March intake from last year. So like she's in between the 2 years from last year and this year. Zoe was here last year as pre-master, this year as master. So we have a bit of continuity, and that's the thing, just having continuity in the projects and the teams. It's something difficult to have when you are only 1 year, especially because after the uni, like you get quickly very busy when you start working. And so, yeah, I think long-term project is like trying to keep the project going and avoid losing the lesson learned and keep the knowledge and know-how we had.
Possibly a bit less exciting goals to kind of help with that is that we do have a lab, but because we have turnover every year, it's not very well organized. Kind of things get lost and mixed up and about. It's not, it's a bit hectic. So what we're trying to do is work more closely with the university to get more established facilities so that future years kind of can come in and there's already an obvious place to work. They can get started more quickly. And it's just a bit more conducive to long-term projects. So that is something we're doing that we'll hope will kind of alleviate the loss of knowledge year on year. But yeah, it's difficult, as Paul says, because it's a completely new group of people. So
this year we do have like a lot of experience from last year, as Paul mentioned. So we have like technical advisors who are helping us build the rocket, and also like previous year team members. So we have like, I guess, 6 or 7 team members from last year who are currently actively helping us build that continuity. So I guess we would definitely start off with building this work culture where previous alumni would get together and help the new batch to make like space projects and CranSEDS. So I guess that's kind of new thing this year.
How can someone join your team?
It is currently really limited to students at Cranfield University. I think it's not uncommon for a lot of teams to kind of limit to people geographically nearby. I think if you were somewhere a bit more like in a city, we could probably expand that to people in the city, but we're not. And it's quite difficult for people to get involved and stay engaged when they're not there in person. But anyone at Cranfield, staff or students, can join. We have people, as we mentioned, from all the different courses, even from the School of Management. It's interesting because like the robotics students tend to be more like rover and satellite, whereas aerospace tend to be rockets. So there's a bit of divide there, but anyone can do anything. That's very motivational. The only actual applications you have to do are for kind of the organizing roles. So project managers have to apply. In the bigger teams, you have to apply to be a team leader. So I had to apply to be an avionics team lead. But yeah, you just have to be keen about space and to turn up, and people really learn as they go along.
To be honest, to join the CranSEDS EuRoC team, you just need to have motivation and interest to build your own rocket, and to learn about rocketry if you don't know anything about it. But at the start, I guess I got quite a lot of messages saying that we don't have rocketry background and this is such a big project. I don't know anything about this stream. We are from chemical engineering. We are from some other management related backgrounds. So these people asked me like, can we join your team? Can we contribute to it? So there are like various work packages that we have. We have like marketing, we have propulsion, and anywhere you fit your role into, anywhere you want to learn something. So especially like this is a big project and we don't have any knowledge or experience, but everybody come together, everybody studies, starts everything from scratch, studies everything in detail, and you can then apply your knowledge accordingly, like whatever field you like. And students get to pick their own work packages, so it's quite free that they get to choose which work package they want to work into. Talking about STEM, so kind of interesting. So this year what we are planning is for our rocket, we need a third payload. So we are doing like 3 CanSat payloads. And the third payload that we are doing is an outreach payload. So in June, we collaborating with the startup in Star are designing a workshop for students where we would be talking about some basics of rocketry. We would teach them like somewhat how to build like EuRoC level rockets. And then we would have a small competition wherein groups of students could come together and build CanSat for us that would be launched in Portugal. So a way for students to get involved with us would be designing our payload for us. So I guess that is kind of interesting because last year we did a similar thing where a Bedford school did design our payload. They did a they did a payload called as Candice. It had a lot of sensors in it, and it's a quite fun project to be engaged in.
As they mentioned, yeah, like when you are students from Cranfield or staff member or anything, if you are in Cranfield or around, like you can join the team like without any requirements on what's your knowledge, your experience, because you can learn and any background is interesting. Like you don't need to be aerospace. You can be like anything, like even finance, like management, media, social stuff. Like that's everything is required, and it's exactly the same in the space industry. Like we don't need only engineers, else it would be engineer. Everything would be designed, but you need like structures, you need management, you need recruitment, you need like community stuff, you need everything. So anyone is welcome, and any skills is welcome, and any skills can be learned. Yeah, so anyone is welcome. And then we grew up together.
We do have 3 rocketry teams. EuRoC's our biggest one. We also have, as Rasika mentioned, the UK rocket team, which is aiming to launch to a height of 1 kilometre. And then we also have a team for competition Mach 22, which will be taking last year's rocket, If Pretty, and launching it in Scotland. But honestly, the biggest team is the best one to join for people that are new and don't know much about rocketry. It's less specialised. The teams are bigger, so there are more people to kind of help teach you, and there's more to do. Whereas in the small teams, people have very specific roles because you have to specialise more.
I kind of remembered a story. Like it happened quite recently. We were filming for our video for YouTube. So while filming, one of our teammates, his name is Christian. He is in avionics. So he brought a camera and he started directing us, like how you should, where you should stand, what lighting should be there. So all these aspects, I guess, like the camera, lights, and the filming experience that he was bringing to the team was quite fun. I remember that he did put an iCard for me to mark as an indicator to stand. And I kind of picked it up and he was like, no, you have to stand right at that place. I need to film you exactly at that position. And he was like, I will direct you. Okay. So you can speak about this. You can speak about this. So it's kind of great that he brought that experience to us because filming is not something that comes in engineering. I guess photography and all is not included, but we do have like Cranfield, like CranSEDS communications team where they are taking like quite a lot of great pictures. There are like blogging sites, so Cranfield University blog site, which we could contribute into. So I guess there are a lot of roles in the team, not only related to engineering, but you could do like social media. So people who like Instagram. So I kind of did that last year. So I was given the Instagram handle and I just took pictures of our team everywhere, posting pictures on Instagram, making us famous. So it's kind of fun.
Can someone join or contribute to an online design review?
Somebody is interested in designing the payload, as I mentioned. So I guess that could be done online as well. So basically, you just have to submit your design idea to us. If somebody wants to contribute online, definitely you could join our daily workshop. So some of our workshops you could do, like it's a hybrid workshop. Some people join online, some people join face to face. So you could join the workshop and contribute to some of the ideas. And I guess to design reviews, we could make a provision where people could get involved. We are planning to have a preliminary design review with our mentors, Ben Jarvis and Russ Strand. So I guess we could come to those design reviews and contribute to it. Following with that, the payload that I was talking about. So we have this amazing payload opportunity where the outreach, outside students could develop our payload, especially students. So I would highly encourage people to participate in that workshop, which would be happening quite soon in June.
How do you manage your team?
So talking about management, we have like different workshops, as I mentioned, work packages, as I mentioned. So every work package has like 2 leads. So mostly the technical leads decide on the technical decisions of the project, like whatever, what kind of structure goes into this, what kind of material to choose. Uh, and from management activities, mostly budget, timeline, and when the main meeting should be there. So we have like a format where every week we have work package meetings where students come together for 2 to 3 hour workshop, and they contribute to the design of the rocket. So if Monday is like propulsion team, then propulsion team comes together. Wednesday is like avionics team. So they all come together, sit in small groups, and manage to do their bit of the project. Then every 2 weeks, once in every 2 weeks, we do have interface issues meet. So solving the different interfaces of the design. So we do have like interface issues between avionics and mechanical, like how avionics bay should be integrated and how the mechanical system should be designed according to it, especially the recovery system and the payload interfaces. So that's the thing. So we do have one meeting in every 2 weeks for that. And as far as progress is concerned, we had our conceptual design review with the mentors. So we have experts from the rocket industry. Russ Strand is our Cranfield alumni who has a wide experience of rocketry and has his own rocketry company called CubeSats Rocketry. So he is involved in this year's project, and he helped us in testing last year. So we did a lot of testing activities with him. And then we have Ben Jarvis, who is quite experienced and quite well known in the rocket industry. And he is the founder of Raptor Aerospace, which is now known as Gravity Lab. And I guess he's working in Saxaford. And yeah, he's the founder of Launch Access Limited. So he supports us. And last year we had our design review with him. So before the final jury design review, we do show our designs to these mentors to get their feedback. Then we do have like technical support, which is from last year's batch. Like Paul is one of the members. So Paul is involved in like avionics support and mechanical support. So we do have people from there as well. And talking about project management tools, basically it's not much tools, but just Excel sheets or Microsoft Word that we use, PPTs to convey messages, and we use like communication mediums. If messages are really important, we do use emails for interface issues so that we have a note of it. And we do have a provision where the team leads make the meeting minutes after completion of every workshop. So every team member who has missed the workshop could attend could read the notes and follow up with the team's current idea that is going on.
Yeah, project management tools really vary by projects. It depends on the scale. So generally, the more advanced project, the more project management tools are used. But that's not always the case. For the team that I run, which is the Mac 22 team, We do use Kanban boards. I'm a really big fan of those. They're much easier to kind of visualize tasks. We just use the Microsoft Teams version for that, and then use Microsoft Project for Gantt charts, which is, I know you can do it on Excel, but Teams or Project's a lot more powerful for that. And then we do tend to meet in person, as we mentioned, but for online meetings, something like Zoom or Teams works quite well. I think some projects have used kind of various other things. I think Airtable, maybe one of them. Every project manager kind of brings their own favorite tools and kind of goes with that. There's nothing kind of standard that we go for.
Yeah, I think like project management is like, you need, like when you're managing a project, is like you need a tool that you like to use and a tool which is like also user friendly for like your team. Because if you have like a tool which is like you love it and like it's very nice, but at the end your team doesn't like, it's not user friendly for your teammates, they won't use it. So you need to be in between like something which is like nice and cool to use, but like not too complex. If it's too complex, people doesn't tend to use it. But like when you're doing like the project management, it's good to have like a full scale. There are for any member that speak just English. I guess for us, it's like people who are struggling to speak English, for example. And because like we're in the UK, but because we only speak in English, except when we are, for example, two French people, we can speak French for sure, which happens a lot. But like people are very, very friendly and open in the team. So when I came last year, like I was not fluent when I start to do project management, but you just need to start at a point, and then you go and it goes. And that's something important, like about when you're speaking different languages, there can be some communication issues. So if you're not sure you understand exactly the person well, like the important thing is just to ask, to repeat, explain another way, because two people can speak together, but being in two different worlds, and that's something that shouldn't happen. And I think by reformulating stuff and so on, that's stuff which when you're managing a project, you need to make sure everyone understand this stuff the same way.
I think it's a really good environment to really work on your communication skills and not just verbal. Like one of the things that really helps is to draw it. If you're trying to describe a design or a process, explaining it verbally, as Paul has mentioned, can go wrong. Obviously, I'm a native English speaker, which means that I often talk very fast, which causes problems for people who are less fluent in English. And just drawing stuff or writing it down as you go can be really powerful for helping people understand when you're talking a bit fast. I just remember last year saying something and you kind of giving me the stare like, and I was like, didn't get that, did you? No.
Yeah, but when it happens, you need to communicate and just say it. And
for sure.
How is the experimental rocketry community in your country?
It's pretty good.
It is.
There are lots of really great rocketry teams. The issue is that there are lots of limitations on high power rocketry, but there are also some big lobbying campaigns to try and get those rules changed so it's easier to do higher altitude launches. So there's definitely progress being made there. But it's a great community. You get people of all ages launching some really quite complicated rockets. At the club that I'm at, I think there are teenagers getting their level ones, and it's very friendly. It's really welcoming.
Yeah, definitely. Like in the UK, it's something quite developed, like the amateur rocketry. Like not as much as in the US for sure, but in comparison to other European countries, I think it's well developed. Like there are several local clubs which launch once a month from Cranfield. Like with 1 hour travel, you can get to 2 launch sites where 2 launch opportunity a month. It's mainly like for low power, mid power, and high power. Also, like you can get level 1, level 2, level 3, but there is a ceiling. In general, it's I think about 3,500 feet, so about a bit more than 1 kilometers altitude, the limitation. But in the UK, there is definitely a lot of amateur rocketers from everywhere, and a lot of university that's has rocketry program.
Talking about the space community, I guess UK is on the verge of lot of development in this sector, as people graduating from universities to start their own companies, especially in the space sector, and we could see that in Space Applications Catapult. And there are a lot of companies doing business to space, or which are involved in doing some really good projects that you've never imagined. I remember meeting one company like Space Forge. I guess it was.
Oh, yes, Space Forge.
Yes, a Space
Awesome.
Forge. I guess they were developing some kind of heat shield.
No. So what it is when you're alloying materials, alloying two metals, if they have very different densities when melted, then they will separate and they won't mix on Earth because you're in gravity. Whereas if you do it in microgravity, they won't separate out. So you heat up the two metals, you allow them to mix properly, then you cool it down, and then you bring it back to Earth. So it's creating alloys in space. It's creating recoverable satellites, which no one does. We talk about like space debris removal. We don't talk about actually recovering satellites.
That's true.
And they had these flight tags, and you know how flight tags are always removed before launch? They're say remove after launch. Sorry, which is very classy. We like it.
Yeah, so like really good projects, and like something you can never imagine. There are a lot of emerging industries and on-orbit servicing especially, and people are developing like rockets, engines. So you get to see space everywhere in the UK especially. Compared to India, I guess there is a lot of development over here in the space community as well. Like there is a lot of companies, and also if some students want to take part in some internship programs, we do have a spin program where we can do some internships with these companies, starting from like after bachelor's degree or master's degree. So it's quite open.
Yeah, UKSEDS works really hard to make those opportunities available. So they did a really good job of that.
Space community in the UK is like large, like because they are like large companies such as Airbus, Thales and Aerospace, which are like building huge projects and like mission, like space exploration missions. Like just saying the Rosalind rover is in Stevenage, like the Sample Fetch rover, the Earth Return Orbiter, which is going to bring back samples from Mars, is doing by Airbus in Stevenage too. So they're like large mission, but the small companies and startups in the UK, it's like really exploding. There are like a lot of market growing, and that's something impressive. Like there are like 2, 3, 4. A lot of launchers, small launchers companies building their own launchers, and I think also 4 spaceports in developments. Mm-hmm. So it's quite large and growing very fast. So a lot of opportunity to work here actually.
Would you like to join the Open Launch Initiative?
Yes, I read a bit about it. So if I understood correctly, I think it's really interesting project. I would be happy to learn more about it, definitely.
Yes, the idea is practically to if many teams go and share the price of a spaceport. I think we have 15 teams, and so if the price is about 60,000, each team can pay less than 6,000.
The difficulty is at the moment, as we mentioned, that we do struggle year on year to find funding. It's quite hard for us to make any sort of financial commitments for next year because we've no idea what we'll have next year. And it will probably come down to either supporting that or going to EuRoC. That's the difficulty for us. It's weird. We're a team that's been around for a long time, but every year we have to treat like we're a brand new team.
Where do you test and launch your rockets?
Oh, this is a tricky one because, as Paul has mentioned, the normal ceiling is about 1 kilometre, and you can do higher launches, but the process to apply for it is a bit more complicated. It can be quite expensive with the motors and with the travel, so we don't want to go overseas just to do testing because that gets very expensive. But a lot of the smaller teams like the UK Rocketry team have done lots of test launches at local launch sites and also drone drop tests because their rockets are quite light. Though they did one recently where they dropped it and the drone the drone dropped their nose cone with the parachutes, and it drifted into a tree. So they had to go up with the ladder the next day to retrieve it, which is always the danger of drop tests. So the problem is that, as we mentioned, people are only here for 1 year, which means that if people are coming into the society with no rocketry experience, they are going to struggle to get their level 1 qualifications or level 2. I think for EuRoC we would need, is it a level 2 or level 3 for the motors?
Last year it was level 2. I think this year it should be just level 2.
Okay, so we would need, that takes a long time to get your level 1 and your level 2 if you're coming into it new. So we can't actually legally launch the rockets in the UK that we do at EuRoC without, we can do, but it's a lot more complicated. Wow.
Could do.
Yeah.
But
it's a lot harder.
The question is, it takes time and you need the budget for. So in Cranfield, in CranSEDS, we were aiming to get the budget, enough budget to finish the projects. And last year it was just good, but not that much margin. But actually testing the rockets depends what you want and what you need to test, what's your requirements. So if it's just structural testing, you can do on the ground, you can make basic, with your hands, you can make basic stuff, just really. And if you want to test your avionics bay, we had a very small vacuum chamber where you can put your avionics bay inside, and you can get some tests like that. And even without that, you could just take a vacuum cleaner and that's with a vacuum cleaner you could test your avionics. And then you can have, we did recovery system deployments testing on the ground with black powder. So we were in a farm, just next to the university, with a farmer allowed us to use his fields, can do tests like that. So at the end, test flight is the ultimate goal for testing. It's the final test before the competition. Obviously, it's not mandatory to get to do it. So definitely it's cool to do it because you're launching a rocket and that's something awesome. But if you don't have the budgets, or if you don't have the time, abilities, you can still get to test your rocket well enough for the launch, have a safe launch.
It's a huge risk as well, because if you have an unsuccessful test, then suddenly you have no rocket a month before the competition. And so if you are going to do a proper test flight, then you have to have the budget and the capacity to create the rocket again. And we don't have that.
I guess I remember last year, we 3 of us went to a place which was 2 hours. 2 hours from Cranfield to drive, and 4 hours, to be honest.
During the petrol shortage.
Yeah, exactly. And we went to some sort of a jungle type of a place to test our, I guess,
it wasn't a jungle. It was a park
by
an estate.
A very dark jungle in the night. We did our pyrotechnic ejection test, and it was so weird. And Zoe was making me stand in the grass. I remember she's like, just shut up and stand there. Just record the ejection.
You were trying to stand too close to the pyro, and it was we must do this safely.
Yeah. I was kind of scared because I thought I would be captured by an animal or something. I don't know. It was not really a jungle, but it seemed like a jungle.
Near London, the most exciting thing you're going to get is a terrier off the lead.
We didn't have petrol in our car, so basically, I guess we were stopping at each and every petrol station to fight for some petrol. And I guess it took us a long time, but it was quite fun, to be honest. We had to test it. And the reason we had to do this because we need a licensed practitioner who is level 3 certified and who can in supervision of whom we could do the pyrotechnic test. So it's quite difficult to arrange such things. And some sort of recovery test as we did with everyone in the team was in the farm, as Paul mentioned, which was kind of fun as well. So we were hogging on chips at that time, standing there, some of the team members trying to assemble the rocket.
Some of us talking to the donkeys.
Yeah. Some of us singing to the donkeys. So we have really great singers who sung a song for the donkey.
How many sponsors do you have?
I couldn't say off the top of my head, and it depends. So we kind of get grants from companies like RS Components and Grassroots Fund. We get support from UKSEDS. We've just signed a sponsorship agreement with another small company. And then there are other kind of longer term support, kind of in-kind support we have with companies as well. So yeah, but all of that goes towards components. It's because most of it is in-kind support, which means that we don't have a lot of operating cash, which we need for rocket motors and for travel.
So talking about sponsors, we do have like collaborations, I guess, from Total Carbide who help us in some kind of components. So they do give us like components manufactured. And last year we had Bedford CNC. They gave some components. So mostly we don't have like monetary sponsors that much as we have like components sponsors. So people do usually like to contribute to buying certain components for the rocket. For example, we did a tie-up with the Launch Access Limited. So they gave us a problem statement on which avionics team is working on currently to design a payload, and in return we are getting some components of rocket structure or some bulkheads and nose cone.
Yeah, I mean, ultimately we would love to join, but we also, it's going to be a couple of years before we've got 6,000 that we can contribute.
Yeah, that's true. And it's a bit difficult to find sponsorships, especially remotely. If you're doing it online, like we don't have like big events because our university is quite in middle of nowhere. We have like an airport, that's why. So it's basically in the middle of nowhere to host events. But CranSEDS is planning some events where companies could come together to have a look into our projects, and I guess we could get a lot from there itself, like face to face. So I think that would be a great opportunity.
How do you promote your team?
We're mainly on Instagram for the kind of fun stuff and the regular updates about the teams, and then we put kind of big updates on LinkedIn. Those are kind of the two best places, I think, in terms of what people are using and looking at. I think we do have a YouTube. We don't tend to use that much, but it is there. And we also like doing kind of member source content. So we really encourage members to take photos and videos, put them on Instagram stories, and then we share those. So that gets us some kind of small ephemeral content as well.
We are doing some video shoots. So I guess we could see them in next month or something once the editing is done. So we are doing some promotions related to our team by making YouTube videos. We have started this anew, and I guess we could have like team working on each of the system and talking about the system. So we might be posting videos of that as well. And we do have a website. So to get in touch with companies, we use our CranSEDS address most of the time, and we have our website to promote the companies as well.
The YouTube channel is populated, not that populated. There is the video from last year conference events. So there are like a lot of content on like the conference we had with like different speakers. It's about space in general, not about rocketry. But you should have a look. You type CranSEDS on YouTube, and there are interesting stuff with some NASA, ESA, other companies, Airbus, Ashford, and other, so some content in YouTube. But yeah, as last year, LinkedIn and Instagram is the best way to follow the team.
What are your plans for EuRoC?
This year, we are building a 2-stage rocket, which is quite similar to last year, but different in design sense and avionics. It's quite different from last year in terms of payload. So we are participating in the 3-kilometer COTS category. We have mechanically actuated recovery mechanisms. So it's kind of interesting. And the key highlight of our project is the state separation. So we would get to see two rockets in one single rocket, as I mention all the time. So we have a pretty huge rocket this year with quite complexities. Talking about the jury pitch technical report. So these are the technical deliverables. Last year, by going to EuRoC, we got a lot of exposure and lot of experience to these events. So we kind of have some plans in mind to have an idea for the jury pitch. Basically, the payload collaborations are quite interesting. As I mentioned, we did collaborate with Launch Access Limited. So this is like a client payload that we are developing. And in this payload, we would have like a commercial CANSAT kit built by the avionics team. I guess Zoe would talk about it more. So in this kit, students who are interested in space could easily operate on this CANSAT in future. So we are building basically a commercial product. And the second payload is like it's kind of developing in process, but it's from the team Mark 2022. Mark 2022 is developing a really interesting payload. So he's project managing that. Like we are going to test the payload over there as well. And since it's a quite good payload, so we thought of incorporating it into our project as well. It's a seed sat, so it would disperse seeds, but it's still in very conceptual stages right now. So this payload is not fixed, might change in future. And the third payload is the outreach. As I mentioned previously, it's a very interesting payload to be developed by school students. What we are planning is like, we are not even planning just to launch a rocket. We are trying to build a community, a workforce where everybody is quite involved in the team to build this mission to work on launch vehicle technologies. I guess this is a great aim of mine, to be honest. So I would like to engage like students, school students, to design this payload.
Yeah, I think the fact the two-stage part is something that is much more complex as it can be thought, especially about everything. But integration, I'm thinking about the integration is more complex than just a single-stage rocket, and that's like this new rocket for this team. The team is like doing a good job to trying to make it more easy to integrate and than last year, because last year it was integrable but not easy to integrate.
The key thing for this year is taking a lot of lessons learned from last year, because that was the first rocket. We didn't have any examples, we didn't have anything to go off. So we're using that as the starting point for this year's rocket. And taking all those lessons learned to make something that's just easy to use, easy to work with, more robust, easier to troubleshoot. So
we did have this lessons learned kind of document from all the advisors that we have now. So everybody contributed to it, but we started taking if pretty as a basis, and we are building on it. So our rocket is based on if pretty full, not entirely, but like majority of things could be kind of similar, but there are design differences. The way we are designing things is like quite less complex, and I guess it's like easily manufacturable, easy to assemble. And following with the complexities that occur in avionics, we have a huge team working in avionics section this year, and we have brought a lot of change. And yeah, talking about the top competitors and favorites. So to be honest, when we went to EuRoC last year, it didn't at all feel like a competition. It felt like more of a collaborative effort. So the teams are really amazing, to be honest, and it's really good to see all the teams having this amazing huge rockets working on liquid rocket engines. Some are like hybrid rocket engines or quite good payloads which are deployable. So it's amazing to have an interaction with all these teams. I won't say we have like competitors or like we are obviously competing, but I feel it's more like a collaborative effort. Sometimes I remember that there were few team members who came to uh, our port, where our booth actually, where they helped us in getting some tools or helping us with some activities for launch activities or sharing their experiences. And in during the night time, we used to assemble near the beach, so we had a beach kind of thing in the near the accommodation, and we used to chat and have fun with each other. So that's kind of really interesting.
You want to join another rocket competition?
We used to go to Spaceport America Cup. Paul, I don't know why we chose EuRoC over that, but Spaceport America Cup is just so much more expensive to attend.
In 2019, the CranSEDS went to the Spaceport America Cup. They launched a rocket, didn't recover it correctly. I mean, it was digged in the ground. Then COVID happened, so 2020 edition didn't take place at all. And last year, 2021, it was only online. At the beginning of the year, like, there was EuRoC that just came out, like, hello, we are new competition. And we were, oh, that's great. That's looking amazing, and let's go to it. And because, yeah, going to the US last year, it was like, we were not sure if it would take place or not. And so finally it plays online, which is interesting, but not as fun as launching a real rocket in Portugal. So yeah, this year I think it's taking place. But the thing is, I think before going to the US, like, make sure you can launch a rocket here. Like, it's lower costs, and that's something. If you have the money, for sure you can go. It's easy, but you just need the money first.
Also, I've heard a lot about Spaceport America Cup being much more actually competitive, whereas, as Rasika said, one of the lovely things about EuRoC is how it's really a collaboration, and there's a lot of teams working together. It's a really friendly environment, and I know some teams do go there to win, but I think honestly we're just happy to have the launch opportunity and just to be there and see what the other teams are doing. That's, at least for me, the most exciting part. So yeah,
definitely. At EuRoC, everyone is here to launch and to make sure everyone can launch. Like, you don't care if like it's awesome to see the rocket launches. Like, you just want the other to launch and recover it. Like, fireworks are cool also, but like, it's better, like, the time they spent, and like, it's always heartbreaking to see failures or abort missions. You wish everyone can launch. And
how do you finance your team?
Oh, the question for the ages. So as we've mentioned, we rely a lot on in-kind support. So that's people providing or sponsors providing components or machining for us, all of that. Because the facilities that we have are really limited. We basically can't do any metal work ourselves, with a couple of exceptions. I know Paul's shaking his head, but it's very difficult for us to do, especially precise machining. And Cranfield University does have some facilities, but it just can be difficult to access those. We do also get some financial support from the university and the kind of associated places, and there are lots of grants that we can apply for in the UK, which really make a big difference.
Yeah, like, it's, as said, like, there are actually good manufacturing stuff in Cranfield. Like, actually, some Webb telescopes parts was manufactured by Cranfield's laboratory. But the thing is, it's not like, when you come in Cranfield again, like, it's 1 year program. Like, you don't know everything that is possible, so it's difficult to get to know the thing you can do, and like, then it's always too late. Like, you need to get your projects, and the lead time is like sometimes too long. And so you could say, yeah, okay, so let's make a 2 year project, and so you have the time to get the stuff. But again, we are 1 year program, so like, it's useless to work like for a project that you're not going to launch. And so to come back on funding stuff, it's like a lot of the team needs to look for sponsors. Last year it was like the majority of the funds were from sponsors, and we limit as much as we could the cost of the rockets. To give a figures, I think it was 3,500 of pounds for the total rockets, which is a lot or not that's a very, very small amount, depending of your perspective. Like some universities spend much more. Other has like same as us. But I think it's really, it's like you need this money, and at the end, if you, it's hard to get if you don't have any sponsors.
We do have some components and stuff like that from last year's team, so we could get those. So there are some components that are like extra, so which we could use in this year's project. 3D printers, basic facilities, like we have 2 CranSEDS lab with tools and stuff like that for manufacturing. So it's not a big manufacturing hub, to be honest, but I think we could do some correction manufacturing work over there like we did last year. Also, we did like the fins, especially the fins were manufactured using like composites, kind of these facilities which we get to use in the labs. The support is concerned, this year we are having support, as I mentioned, from Total Carbide. We are having support from Launch Access Limited. We are having a lot of support from Cranfield, since they saw our performance. Like we managed to build a rocket last year, and we went to EuRoC as well. It has become quite famous in our university, and more people are joining from the university itself to support us.
How much do you build your rockets?
Between do it yourself and buy cuts, so commercially off the shelf components, you need to have this trade-off. In general, like sometimes commercial cuts components are like more expensive, but you know it's going to work. You buy it and you can use it directly, but you don't have any research. So it's good to have like some do it yourself, but it will take time. So you need to limit, like to get this balance between the stuff you develop and research yourself, and the stuff you buy commercially off the shelf. And so last year we had, like, for example, the fins were manufactured by ourselves directly, like from carbon fiber, and that was a real cool stuff to do. And then like we bought some rings for like the rings, centering rings, bulkheads and so on in aluminium. Then like we manufactured the last like adjustments were done by ourselves, like the holes, tapping of the holes and so on. So it was kind of a trade-off. But for this year, like it's maybe a bit different. I don't.
What we are doing is, as Paul mentioned, a balance. So we do look for facilities that are currently available in the campus. To be honest, we do have a lot of manufacturing facilities, but the access to them is limited to the specialized courses they are into. But we do have some machines, as I mentioned previously, like 3D printers and stuff like that. Then we can't manufacture our own engine, so because it's not permitted in the UK. But I guess hybrid rocket motor test stand is doing that. On EuRoC especially, we are the components such as fins and some internal components such as bulkheads and all, which are usually glass fiber, that could be manufactured in the CranSEDS lab itself. So yeah, we are finding the balance between them. What materials are available? What objects are quite complex to manufacture in our lab, which we could outsource. So it's really a balance between all of those.
What software do you use in the rocket?
We keep it pretty simple. We all get familiar with OpenRocket, a classic. For the structural design, it'll often be CATIA or SolidWorks, depending on the team's preference. I know when CFD is done, people tend to use ANSYS for that. And then at the moment, we're doing some PCB design. So we use Autodesk Fusion for that because we can get free access to that as students. We don't tend to do, I guess you could call it software development. That's for our Arduinos and Raspberry Pi payload that we're doing. The satellite and rover teams, though, to be honest, do a lot more software because they have a lot more kind of processing power on board, and they often have a lot more kind of analysis that they do on board. So they need more software focus for that.
Starting with the propulsion team, we had like our team using MATLABs to do the entire calculations and finding the right COTS motors for our rocket. So mostly they did a MATLAB simulation. Then they also relied upon the open rocket model, as Zoe suggested. So starting for the baseline, we for starting from zero, we do rely on open rocket, and then we develop on it design wise in software tools like SolidWorks. This year we are using SolidWorks. For analysis, we are using for CFD obviously ANSYS, and for finite element modeling and simulation, finite element simulation, we are using the Nastran Patran software. So it kind of comes with the Cranfield University course, which is quite easy. So we are using that.
You can't use thrust vectoring or airbrakes or something to control your flight?
So from an avionics perspective, no. It's just a bit of extra complexity. We already have the two-stage, which adds a lot of extra avionics work for us, and we just don't have the in-team expertise or hardware or software experience to really do the attitude control of the rocket. That could be something for future teams or future years, but not currently something we do.
Yeah, the only thing which, two-stage is already a lot of complexity, and Airbrakes, those teams are using it like to get the apogee as close as possible as to the targets. But with the two-stage, we have this possibility of choosing the second stage ignition, and there is a trade-off between giving like more vertical motion through your thrusts, or like having more drag, or waiting a bit longer before ignite the second engine and having less drag. So there is this trade-off that we can make, but we stop to the two-stage. It's complex enough.
What kind of fins do you use?
It's basically trapezoid fins, in carbon fiber. Last year they were made of, so made by ourselves, and they are mounted on a fin set, so a tube which is like a copper, like it's a different frame to the airframe. So like we can change actually the fin sets from each stages, which is modular, and make it if you have a hard landing and one of your fins is broken, you just change the fin set and you can go again.
What electronics and sensors do you use?
Obviously, for the EuRoC competition, we have to use a commercial off-the-shelf flight computer. So we use the egg timers for that. We know how they work. We like them. They're quite cheap. Our student-developed flight computers will have one in each stage, and we will run a circuit board for that, a custom PCB, and we work with someone who gets those printed for us. The computers we use are Arduino Nano BLE sensors, which come with an inbuilt, I think, 9-axis gyro and barometer, so it can give us altitude, it can give us kind of angular acceleration and so on, which is really useful. We can also obviously kind of test that to a certain extent to the ground, and Paul has mentioned that we have you've got one there. Very small with like all the sensor included, so kind of useful. I love them. I think they're great. And yeah, we can test them, as Paul's mentioned, in the vacuum chamber. So when we've got our PCBs printed, we'll be doing a full scale test of all of that. In terms of cameras, we'll definitely have one, because there'll be one on the payload we're developing with Launch Access Limited. And depending on whether we get a clear hatch over the avionics bays, we might have some in the avionics bays as well. But that's very much to be determined at this stage. Egg timer for avionics. I forgot you'd nicked half our flight computers.
How do you transfer data from the rocket to a computer?
This is something new we're going to do this year, is try to have in-flight live telemetry. One of our team members, Josh, is really experienced with amateur radio and antennas and all of that. So I don't know anything about that, but he does. So what we'll have for our the telemetry part of our ground station will be basically a handheld antenna attached to a dongle that goes into a computer, and that computer will kind of decode it, translate it, and hopefully we'll come up with some nice graphs that show all the data that we're receiving. So we'll need a bit of processing there. The antenna that we'll use on the rocket will be a commercial off-the-shelf one. We will also have, obviously the egg timer stores all the flight data itself. We'll also have an SD card reader with the Arduino, so that stores the flight data. Because for the competition, we need to have altitude recordings so that they can, so they can mark that. We probably won't have an auto tracking camera for the launch video. We're not quite that advanced, but we'll see what we can turn up with. Yeah, I think that's about it. We're still kind of working on that because that's not something that a lot of us have expertise in. So we're learning a lot on that front.
What launch rail do you use?
We're not really planning to do a test launch for the competition. We'll turn up and use what they've got. We won't be doing on-rail battery charging. We'll charge beforehand. Last year we used disposable 9-volt batteries. This year we're looking more at using the rechargeable LiPo batteries, but that would be on the ground, not on the rail. What we do attach to the rail is a brake wire. So we use a brake wire as a kind of a safety feature so that the air start ignition motor, the upstage motor, definitely won't ignite until the brake wire snaps and it detects it's left the launch rail. So that's about it for attachments to the launch rail.
What recovery system do you use?
So basically, we have a piston-based nose cone ejection mechanism. We have a bucket where we put parachute. So there is like main parachute and rogue parachute, and it is attached to a piston. So the piston then, once the igniter ignites the piston, it releases the compressed gas, and then the piston just tosses the nose cone off. The nose cone is basically attached to the body tube with shear pins, so it could be easily detachable. We are using this as our recovery system for the top stage and the bottom stage as well. For the bottom stage, the nose cone, instead of the nose cone, we just have the tube coupler, interstage tube coupler. So we just separate that. And for the main parachute release, so we have dual deployment recovery mechanism as specified by EuRoC. We have a drogue chute deployment, which happens with the piston itself. Then we have the main chute deployment, which happens with the tender descender. So it's a device with some quick links. So we are using a main parachute bag, and then the quick links just separate to pull the parachute out, the main parachute out of the rocket. And talking about the stage separation mechanism, so there are some ideas. For now, we are just going by booster stage ignition. Top stage ignition. So the avionics would directly ignite the second stage, and we would have some sort of vent holes which would release the gas enough to separate the bottom stage from the top stage. We do use different parachutes for the top and bottom stage. It was a requirement from EuRoC. It's necessary to identify which is which stage and to locate the rocket basically. So yeah, we do use the main parachute colors are different. It's mostly red and orange or something like that.
Yeah, a last short comment is like both stages are using similar recovery system. So it's the same, exactly same principle, just not, it's like last year it was 2 different diameter of body. But so apart from the sizing, it was exactly the same principle with the buckets, the ejection principle was exactly the same for both stages. Just for the lower stage, the booster one, you just imagine that the interstage part on top is as a nose cone, and that's it. And then the nose cone is ejected, and yeah, that's it.
Do you play Kerbal?
Yes. I think it's a great game, and you can learn a lot from it. In terms of rocketry, yes, I think it's go from it's more about larger rockets and then going to space. Small projects like EuRoC. I mean, small project that you can build yourself with you and the money you have. It's not the same size as projects in Kerbal Space Program, but definitely Kerbal Space Program, you can learn a lot. Personally, it helped me to get my job. So yeah, definitely you can use it even in interviews. I've done it. It worked quite well. And so yeah, play Kerbal Space Program. It's a good game. Hopefully the 2 is coming soon. 1 year to wait.
What's your payload?
So we have like 3 CanSat payloads. One which is a launch access limited client payload. We are developing a commercial CanSat kit for students that is done by our avionics team. I guess Zoe could detail more on it. Then we have the SEEDSAT payload, which would be able to disperse seed in flight. It has a seed dispersal mechanism which works on servo motors. It just rotates and disperses numerous seeds outside the rocket. And the third payload is our outreach payload, which is not yet designed, but is open to competition from June onwards. So once we start the competition, we would have the third payload as well.
Do you have any big announcements?
I don't think so. I think we're just really excited to go to EuRoC this year. We do have the CranSEDS conference hopefully coming up soon on the 29th of June, but keep an eye out on our social media channels for that. Can't say anything about that just yet. But yeah, excited to bring another 2-stage and actually launch it this time. We are launching last year's 2-stage at the end of June at the Mach 22 competition in Scotland. So we'll post more about that as well, because I think that'll be, a lot of people were really hoping to see that launch at EuRoC last year. So it'll be really satisfying for that to launch then.
Yeah, so to give a bit of feedback from background on last year. So we were able, we passed all the flights readiness review, launch readiness review. We went to the launch pad and had electrical issues on the launch pad, and we hadn't time to make it repair and fly. It was a stupid thing. With maybe 5 minutes more, we could have made it. But yeah, that's when you're out of the time. You have a launch window, and it's time. When you're running out of time, that's it. So yeah, for all the team that came last year, Zoe is leading the team this year to launch it in one. I think, yeah, about
a month. Yeah,
about a month. Mm-hmm. So end of June. I don't know when the video is going to be released, but end of June should be some nice footage.
We'll make sure someone comes along with a good camera.
Yes.
Are you going to be there, Paul?
It's in the middle of there is a Cranfield graduation in the same week. So
skip graduation. Who cares?
Yeah. Well, I paid it.
Well, I guess some challenges to work in this this kind of a project is team management. Usually people have quite hectic courses, IRP and GDP, and it's really difficult to get each and every team member actively involved in the project. And at times there are times which are really difficult where some sort of team members, we start losing team members, but there are new additional entries as well. But losing team members is obviously not a good thing. So this is kind of a challenge to hold the team together.
I think by challenges, it doesn't mean challenges we face. It means, do we have any challenges to give to people?
Yeah, so the challenge that we would be giving people is to design our payload so it would be on the top of the nose cone. This would be our final payload launching to EuRoC.
Paul, you've got a job. You go first.
I'm already flying some satellites currently, so yeah, working at Ashford scale. So it's like a company working on space sustainability. So it's kind of a very nice project. Yeah, to make sure there won't be too many space debris in orbits in the next years, so that future generation still can use space. And so yeah, it's kind of super interesting job, and the aim of the company is kind of cool. So yeah, that's where I am.
I think hoping to go into the design development of liquid rocket engines. I think that's the area I like the most. So keeping an eye out for jobs on that basis. But anything to do with space, to be honest, it's all exciting. It's all happening. So yeah.
I'm personally joining the aerospace propulsion department, so mostly related to either aircraft propulsion or rocket propulsion. I would be happy to join them, and yeah, that's it. And I guess in future I would start my own startup. Who knows? A small rocketry startup itself.
Do you have any advice for young Rocketeers?
Go for it. Just try, crash, fail, repeat. Like, be careful. Like, it's still dangerous stuff, but it's by doing it by yourself or by yourself or a team that you learn the most stuff. Like, you don't need to be an expert. It's not like rocket science. Come on.
Ha ha ha.
Rocket science is no longer rocket science anymore.
Definitely.
I think probably the biggest thing is find a local club or society to join, because you go along to these events, you learn so much from people who've been there for a long time. And I say at the local club that I'm at, there are so many really young members who are already getting their certifications. But also it's never too early. You can go when you're very, very small, but it's also never too late. You can get into it at a hobby at any time with any background. So.
Yeah, and today, like, there are so many resources on internet. So yeah, there is no reason not to start.
What are your favorite space movies or YouTubers?
I love all the space movies. I won't list them because we'll be here all day, but there's a lot of fantastic science fiction out there. This isn't technically space related, but the YouTuber Explosions and Fire is really great if you want to kind of get more involved in the pyrotechnic side of things. Do it legally. Be aware of your local regulations. That's all I'll say on that.
For me, I would say The Martian is one of my best favorites space movie. It's like kind of realistic. Like they done a good job on it. And YouTubers, I think BPS Space. I really like what he's doing. A lot of learning, and like he's sharing his successes and failure and fun stories, and yeah, kind of you learn a lot from him.
Talking about favorite YouTubers, I would take name of Copenhagen Suborbitals, one of my favorites. They have given us a lot of access to how actually rocket engines are manufactured, especially the injectors. And then obviously, as Paul mentioned, Joe Bernard is one of the greatest YouTuber in the rocketry industry itself. His building Lumineer series is quite interesting. Apart from that, Scott Manley,
You've got to have Scott Manley.
Yeah, he makes great videos on details of how pumping works, injectors work. So every details. So if you want to start from somewhere, if you want to start learning about rocketry, so I highly recommend these channels to start off. And favorite space movies definitely would go for Interstellar, because father-daughter relation, quite interesting. Daughter gets older than the father. Quite fun.
I like Star Trek.
Yeah, actually, if you really start rocketry, have a look on Apogee Components. So they are like sellers of rocket stuff from the US, but they have a lot of videos with like really the basic stuff. So to learn like when you start from scratch, it's a good source. They have a lot of videos.
Do you have any questions for me?
Have you launched a rocket before?
I think I've lost count. I've done like sugar rockets. I've done, I don't know, I would guess like 100, but probably less.
That's more than us, definitely.
That's awesome.
They were small. They were like sort of like this, and they were all like this, so smaller.
There's a skill in doing small rockets. There's I'm part of a local like rocketry club, so I've only done about I think 7 launches now with my rocket, which is only about that big. And there's a guy who specializes in like micro rockets, about this tall, launching on A or B class motors, and that's a skill in itself.
I just had engines. I made my own engines, and I just ignited the engines. I didn't make like fins or nozzle or things. I just did the engine and I made it fly. That's
The
why it
engine's
was
the fun part.
Yeah, I agree with that.
Well, in the UK, the explosive regulations are really, really tight. So you can't make your own solid motors. That's illegal. What are you going to do in the space industry?
Exactly.
Yeah.
Rockets.
Yes. Which bit of rockets, though? Yeah, like, do you want to do more kind of guidance navigation, or is it all about the rocket motors or structures, or
Sending stuff to space like Mars, maybe Jupiter, Saturn, Alpha Centauri. So that's sort of
Oof.
far away. That's
That's
sort
a
of far
trek.
away.
You can do it.
You need some serious advancements in the space technology to go to Alpha Centauri, that's for sure. This is like 4.2 light years. Even if we go at the speed of light, that's a while. 4.2 light years.
Yeah.
Yeah,
We
definitely.
We just need to be like Star Trek and create warp drive somehow.
Even like at warp 4, then it would still take a year.
I cannot express how happy I am to meet another Star Trek fan. Yes, it would. I mean, I think they've got up to warp 5 by Enterprise, so we'd probably be looking at 7 or 8 for realistic interstellar travel.
Although we still don't have warp drives.
We don't. That is the big flaw there.
That's the big flaw with warp drives. They don't exist.
Yeah, mathematically possible, but we can't play with antimatter yet. So yeah. Anyway.
And so, Eto, at the moment, like you're doing like some rockets or stuff, rocketry.
Yeah, so I did the rocket candy and stuff with Rocketry candy. Then I just thought, well, if I want to go to the moon, it's going to take a very big amount of rocket candy. So maybe it's going to be better to go with something more efficient, like a liquid-fueled rocket engine.
Yeah,
Now I'm building them. It's harder than it seems.
Yeah,
Definitely.
You get very good at plumbing.
At a very young age, you started this YouTube channel. So where do you get this inspiration from? And like, who are your key inspirations from the space industry?
Okay, so at the start, I just watched lots of videos and like I was like, oh, I want to make videos too. And at the start, there was Minecraft, then Kerbal, now interviews. And just like for Minecraft, it was like I played Minecraft and then I had an idea. Oh, this would be nice to make into a video. And the same for Kerbal, did this, that. And for the interviews, well, I do an interview and I publish it.
Yeah, but really congrats, like doing interviews with like all the EuRoC teams, like it's kind of, yeah, interesting and good job. And like it's also good actually, like even like for us, like it's cool, like we get to know the teams, like the new teams, so yeah, it's really good job, man.
So thanks for joining me.
Thank you so much for inviting us as well. Like, it's a great opportunity to talk about our rocket. It's a great platform. I guess it's quite famous on LinkedIn. I every day get your post. Like the first post is always related to some rocket interview done by Etocraft. So thank you for having us to this platform.
And thank you for coming.
It's a pleasure.
Yeah, thank you. Thank you for the invitation. Also.
Have a good week.
Bye-bye.
Goodbye.
See you.